It's time to learn about simplifying radical expressions. Product rule for radical expressions. Product means to multiply. Hopefully you've noticed the definition. Read the note. And what I want to point out here is that we cannot multiply those two together because we have an index, the indices are 2 and 3. So let's get started. Multiply each radical expression. So we have the square root of 5 times the square root of 20. 5 times 20 is 100. And the square root of 100 is 10. Number 2, we can multiply the radicands because they have an index of 3. So negative 3 times 9 is negative 27, and the cubed root of negative 27 is negative 3. Number 3, we can multiply 1/3 times 148, and we get 1 over 144. And if we simplify, that is 1/12. And number 4, we can multiply 1/3 times 1/9 times 1/3. That's 1 over 81. And the fourth root of 1 over 81 is 1/3. All right, let's take a look at our quotient rule. Quotient means to divide. And you can notice that we can split the radical sign and put it in both the numerator and the denominator. Or if it's in the numerator and the denominator, we can write it as a single fraction. So here we go. So I'm going to write this first as the square root of 18 divided by 2. 18 divided by 2 is 9. The square root of 9 is 3. Number 2, I'm going to write this as the cubed root of 135 divided by 5. Simplify 135 divided by 5, and that's 27. And the cubed root of 27 is 3. And the same with number 3. I'm going to simplify this. The square root of 4 is 2, and the square root of y to the 4th is y squared. Y squared times y squared is y to the 4th. So now I'm going to give you a step-by-step way to simplify radicals. And we've kind of used this in some other videos already. To simplify radicals, step 1, find the prime factorization. Step 2, determine the index of the radical. The index tells you how many times, how many of a kind you need to put together to be able to move that number or variable from inside the radical to outside the radical. All right, step 3. We're going to move each group of numbers or variables from inside the radical to the outside of the radical. If there are not enough numbers or variables to make a group of 2, 3, or whatever is needed, then leave those numbers or variables inside the radical. And finally, step 4. Simplify the expression both inside and outside the radicals by multiplying. Multiply all numbers and variables inside the radical together. Multiply all numbers and variables from the outside together. All right, let's put this into practice. All right, you might remember prime factorization by making factor trees. So I'm going to make a factor tree for 98. Two numbers, any two numbers that multiply to give me 98. I'm going to say 2 times 49. And 49 is 7 times 7. So the prime factorization of 98 is 2 times 7 times 7. The index is a 2 because it's a square root. So we need two of the same numbers. We need a pair of the same. So I circled the 7. So 1 7 comes out, and what I did not circle goes back under the radical sign. All right, number 2, the prime factors of 112. You can pick any two numbers that multiply to give you 112. I'm going to pick 2 times 56. And then 7 times 8. And 8 is 4 times 2, but it's also 2 times 2 times 2. So the prime factorization of 112 is listed. I would take a couple seconds and multiply that back together to make sure I get 112. So I look at the index. The index is a 2. It's a square root. So I'm going to circle pairs of numbers. So I have a pair. I have a pair. So I'm going to bring those out in front. And what I didn't circle goes back under the radical sign. I multiply the numbers I have in front. 2 times 2 is 4. So the answer is 4 root 7. I just want to take this one step further and show you how this same prime factorization would work if we had the cubed root of 112. We would still find the prime factorization, but this time the index is 3. So we need 3 of a kind. So the 2 would come out in front, and what I didn't circle would go back under the radical sign, multiplied together. 2 times 7 is 14. And I need my index in there of 3. Let's take it one step further. And what if we had the 4th root of 112? Again, we have the same prime factorization. The index is 4, so we need 4 of a kind. And then what we didn't circle goes back under the radical sign. So the prime factorization is a technique that's going to work regardless of the index. So that is why I have selected this method to simplify radicals. So let's keep going. We have the square root of 80. So I'm going to find the prime factors prime factorization of 80. The index is 2. I need pairs of the same number. Again, I have 2 pairs of 2. So that means I have a 2 on the outside, a 2 on the outside, and then the square root of 5. So simplify this, we have 4 square root of 5. And again, if you have a TI-30XS multi-view calculator or some of the Casio calculators, it will simplify square roots for you. And you can check those answers, but it will not simplify the following. All right, number 4. Number 4, we're looking for the cubed root of 72. Let's find the prime factors of 72. You can multiply any two numbers together. I've just selected 9 and 8. The index is 3. We need 3 of a kind. So we're going to pull a 2 out in front, multiply the remaining factors back together. And that's it. All right, number 5. We want the prime factors of negative 54. So I'm just going to work with 54 right now. So I'm going to go 9 times 6. And then I'm going to circle 3 of a kind because the index is 3. And then since we have an odd index and a negative radicand, I know that my answer will be negative. And then the factor I did not circle was a 2. And since this is a cubed root, I will need the cubed root of 2. Number 6, we want the fourth root of 243. So we need to find the prime factorization. Three times 81. 81 is 9 times 9. So we need 4 of a kind in our group because the index is 4. Notice there's already a 2 out in front, so we're going to have to take 2 times 3. And then we'll have the fourth root of 3 because there's a factor of 3 we did not circle. And 2 times 3 is 6. So 6 fourth root of 3 will be our final answer. Now let's make this a little more interesting and add some variables. The same steps apply. So the square root of 81 is 9 times 9, so we know that that's going to be 9. X to the 8th and you need groups of 2. You have 4 groups of 2. And in a previous video, we kind of figured out that we could just take 8 divided by 2. How many groups of 2 are in 8? And the answer is 4. Feel free to write it out. Number 2, let's find the prime factors of 20. So we have a pair of 2s. And then I'm going to go ahead and leave a space and put 5 back under the radical sign. A to the 5th means I have 5 A's. I need groups of 2. I have 2 groups of 2 and 1 left over. And B to the 10th, how many groups of 2 are in 10? That'll be 5. So we have B to the 5th in front. And that's our final answer. Moving right along. Number 3, the cubed root of negative 729. And you could put that in your calculator. You can also make a factor tree. But 729 is 9 times 9 times 9. Since it's an odd index, negative radicand, I know my answer is going to be negative 9. Then how many groups of 3 are in 6? 2. So this simplifies to negative 9x squared. Number 4, we need the cubed root of 24x to the 8th. Let's find the prime factorization of 24. The index is 3. We need 3 of a kind. How many groups of 3 are in 8? So there's x to the 8th. We have 2 groups and 2 left over. Number 5, the 4th root of 81 x to the 5th y. Well, 81 is 9 times 9. And you could use your calculator. So the 4th root of 81 is 3. X to the 5th, we need a group of 4. So we have a group of 4. But then we also have 1 left over. And y to the 5th, or sorry, y, we don't have enough y's to take any out. So we just put it right back under the radical sign. Number 6, a couple ways to do this one. You can multiply this together. If you choose, you get 3 times 3 is 9. M times m cubed is m to the 4th. Then if you simplify this, the square root of 9 is 3. M to the 4th, how many groups of 2 are in 4? And you can get your answer that way. Another way to do the same problem is, since you're multiplying, you can just list the factors. So we have 3 times m times m, m, m. So we're looking for the square roots, so we need pairs of numbers. So we have 3m squared. Either way is fine. The same with number 7. You can multiply those together and find the 5th root, or we can just find the factors, and that's what I'm going to do. So 4 is 2 times 2. And 8 is 2 times 2 times 2. And then we have times z times z. The index is 5. So we need groups of 5. So our final answer will be 2 5th root of z squared. Number 8, all we can do is multiply the radicans together. Because they're not the same, it's not a perfect square. So we can leave our answer as the 2 factors, or x squared minus 121. You don't necessarily need those parentheses. I just put them on there so you know that it all stays together. All right, number 9. I'm going to write this as 1 radical. The factors of 4 that add to 4 will be 2 and 2. So the numerator factors to x plus 2, x plus 2. We have an x plus 2 in the denominator. Those will divide out. So this will just simplify into the square root of x plus 2. Proving once again, factoring never goes away. Number 10. Let's make the prime factorization of 75. So we have the square root, so we need groups of 2. X squared, we have one group of 2. How many groups of 2 are in 9? 4, with 1 left over. Number 11, we have an odd index with a negative radican. That's okay. We just know our answer is going to be negative. So I'm just going to write it down there right now. Going to find the prime factorization of 56. I'm going to go 2 times 28. The index is 3. I need 3 of a kind. Moving on to the x's, how many groups of 3 are in 7? 2 groups with 1 left over. And how many groups of 3 are in 11? We have 3 with 2 left over. And I would encourage you to go ahead and take the time and write out your variables and circle groups of. And our final 2. All right, number 12. They have different indices. We've got an index of 3 and an index of 4. So let's write this as x to the 2/3 times x to the 3/4. Same base multiplying, keep the base, add the exponents. 2/3 plus 3/4 is 17/12. And there you have it. And number 13, a little bit of stretch here, but you can do it. Again, we have an index of 5, an index of 3. So we will rewrite this as xy cubed to the 1/5 times xy to the 1/3. We're going to use our power to our power rule here. And we get x to the 1/5 times y to the 3/5 times x to the 1/3, y to the 1/3. So we have x to the 1/5 times x to the 1/3 times y to the 3/5 times y to the 1/3. Same base, multiply and keep the base, add the exponents. So we're going to add 1/5 plus 1/3. And for our y's, we're going to take 3/5 plus 1/3. And 1/5 plus 1/3 is 8/15. And 3/5 plus 1/3 is 14/15. And there you have it. Hope you enjoyed simplifying radical expressions. That's it for me for now.